Hello, this is Dr. Ali Sekman from Computer Science Department at Tennessee State University. I'm a professor of computer science. Today, I'm going to give you a brief introduction to Java programming language. I'm going to talk to you about the steps that you need to do in order to write your first program. It's going to be a fun class. I hope you enjoy it. So let's go ahead and get started. This is for Comp 3110 Java programming class, and this is lecture 1, introduction to the subject. Let's talk about first what Java is. I strongly recommend that you watch the video that I prepared for the history of Java, and it briefly explains Java and the other programming languages. Java is an object-oriented programming language. In object-oriented programming languages, the main unit is a class. Think about class as a blueprint. Think about a building in Nashville, for example, the building that we have, AT&T Batman building. In order to have this building in different cities, all you need to do is to use the same blueprint. So the blueprint that you have is the class, and each building that you create is an object. I'm going to talk about this example later in this lecture. It's a simple programming language in the sense that you can understand and learn that pretty easily. It may take a little bit time to get used to the syntax, but once you get the syntax, the concepts are pretty easy to learn. And it's highly related to C and C++ programming languages, but it is not just C and C++ are not the only programming languages that were inspiring the Java developers, but there are some other languages like Smalltalk and Lisp. When Java was developed using C++, the developers soon realized that C++ was having some troublesome concepts that needed to be eliminated. For example, C++ has a concept called pointers, and that may lead some programmer errors easily. And Java programming languages, they eliminated that concept. Another concept that C++ has is that when you create an object and every object occupies memory space, you have to delete the object explicitly. Otherwise, even though when you close your program, that object may still be stuck in the memory, and after a while, you may get a memory leakage problem. In Java, we have something called garbage collection. Java keeps tracks of all the objects that are created, and when an object is no longer in use, Java marks it for garbage collection, and whenever Java virtual machine is available, that object is deleted from the memory so that space is freed up. It's a high-level programming language. That means it's easily understandable by humans. There are some low-level programming languages, such as assembly, but Java is pretty easy to understand. Let's talk about different types of Java programs, and then I'm going to explain to you what we're going to focus specifically in this class. Of course, there are different kinds of Java programs. For example, Java applets. Java applets are designed to run on web browsers. For example, Internet Explorer, Google Chrome, Safari, and so on. Applets are client-side software. In other words, the whole program is first downloaded to your web browser, and it runs on your local computer. And they were pretty useful, especially to provide dynamic web content. Early browsers typically had static content, but with the addition of Java and Java applets particularly, we started having animated images and things like that. So it brings more dynamic contents to the web browsers. The other kind of programs are Java servlets. They run on web servers. If you don't know what a web server is, I strongly suggest that you study a little bit. Web servers are computers that are in remote locations, and they do a lot of processing for you. For example, when you go to eLearn to learn this class or to download this video lecture from eLearn, your request is sent to the server. Server processes the request and send you back what you want. So all the processing is done on a server, as opposed to Java applets, the processing is done on your local computer. So therefore, Java servlets are server-side programs. And there are Java applications, which is what we're going to focus in this class. They are developed on a computer and they run on the same or other computers. And this is exactly what we're going to do in this class. So we are not going to focus on applets, servlets, or any other kind of Java programs, but we are going to do Java applications. The main reason for that is that the goal of this class is to teach you the fundamentals of Java programming. And Java applications are sufficient to learn all those concepts. Starting from very basic in this class, we're going to all the way multi-threaded programming, exception handling, collections, some advanced concepts in Java using Java applications. So let's talk about how to write Java applications. In order to write a Java application, that's a very simple thing. You're going to open a text editor. You're going to write your program. I know you don't know how to write it yet. You're going to save it. When you save it, you're going to give extension .java. For example, you write your program on a text editor, save it as test.java, and then you will need to compile it. Compiling means Java is going to look at your program, check the syntax. If the syntax is correct, Java is going to compile it. In order to compile it, you're going to go to command line interface. If you are using Windows operating system, command line interface is run by command prompt app. If you are on Mac operating system, in order to access command line interface, you have to run terminal. So you're going to go to your terminal or command prompt, and you're going to type Java C space test.java. C stands for compile. Compiling means Java will check the syntax, and if everything is okay, Java is going to create a file for you called test.class. Then that file is runnable. That means you can run that file that's created for you. In order to run it, again, in your command prompt or terminal, you're going to type Java without any letters, and then space the name of your program without any extension. That's practically it. It is extremely easy. I repeat, you first open a text editor. It may be text edit in Mac operating system. It may be Notepad in Windows operating system. You're going to write your program, save it with a name.java, and then you're going to compile it. Compiling means checking the syntax of your program. And in order to do that, you're going to type Java C space the program name.java. And in order to run your program, you're going to type Java space test on terminal or command prompt in Windows. So we'll see those step by step. Do not panic if you don't understand. That's perfectly okay. You're going to see it in action today. All right, so here is how Java becomes platform independent. First of all, what is platform independency means? Platform independency is when you develop a program. Let me give you an example. Assume you develop a program using Windows operating system. That's perfectly fine. You compile it, and then you take the program that has been compiled and try to run it on another operating system, such as Mac OS or Linux or Unix. If that program runs in different operating system, your program is platform independent. This situation is different with C and C++. They are not platform independent. For example, if you write a C++ program, if you compile it, you're going to get an executable program for the underlying operating system that you compiled that code. For example, if you write C++ program, compile it in Windows operating system, you will get an executable program, and that executable program is only runnable under Windows operating system. If you take that executable program and try to run on Macintosh operating system, you are going to get an error. In other words, C++ is not platform independent. However, Java is. The idea is very simple. Let me explain. First, you write your code, test.java, for example. This is called source code. You open a text editor, you write it, you save it. Then you go to command line interface. Again, as I said, either terminal in Mac operating system or command prompt app in Windows operating system, let's say. And then you do compiling using Java C. You type Java C space test.java. And then instead of creating an executable program for the underlying operating system, Java creates an intermediate code for you. And that code is called bytecode. And the extension is class. So you write your program, you compile it, you don't get an executable program, but you get an intermediate level program, which is called test.class, assuming the name of your program is test.java. This program, that bytecode, is operating system independent. Whether you compile it in Windows, Linux, Mac OS, Unix, iOS, wherever you compile it, the same bytecode will be generated. What makes Java platform independent is the Java virtual machine that you install. You install a different Java virtual machine for each operating system. For example, when you install Java on Windows operating system, you install Java virtual machine for Windows. If you do it for Mac OS, you install Java virtual machine for Mac. For Unix, Java virtual machine, in other words, JVM for Linux is installed. Similarly, for Linux, you install Java virtual machine for Linux. Java virtual machine is platform dependent, but as programmer, you don't care about this because Java developers has already taken care of the complexity. So each Java virtual machine has a Java interpreter in it. And Java interpreter knows how to interpret the bytecode. So when you try to run your test.class in Windows, it's going to make a call to Java virtual machine for Windows, and it knows how to interpret your class file for the underlying processor of that particular platform. But if you take test.class and you try to run it in Linux, Java virtual machine for Linux knows how to interpret that bytecode as well and convert it to an executable for the underlying platform. So that's how Java becomes platform independent. The idea is very simple. Again, when you install Java, you install a virtual machine on your computer, and each virtual machine knows how to interpret the bytecode that is generated after you compile your program. However, for C++, you have your source code, you compile it, it's automatically converted to an executable program for that particular platform. And you cannot take that executable program and try to run on another operating system. Just to sum up, you write your program, you compile, you get an intermediate level code, which is called bytecode. And the bytecode is the same regardless of the platform that you compile. And then the bytecode is interpreted for each Java virtual machine for each platform. So whichever platform that you have, that particular Java virtual machine knows how to interpret the bytecode that you have. So that's why it is operating system independent. Again, the platform independent part, test.class is platform independent, whether Windows, Linux, Mac, and so on, it generates exactly the same bytecode. However, virtual machine platform is platform dependent. Each operating system has its own Java virtual machine, and each Java virtual machine knows how to interpret Java bytecode. I hope this is clear. So program structures. Now we are getting started. From this point on, I expect that you have to understand everything 100%. And the way I design those lectures is that it always connects dots. Maybe for a while, you may not fully understand, but in the upcoming minutes, I expect that the dots are connected and you understand. So you need to place your code in a class. So Java is an object-oriented programming language. Everything is class-based. So even a simple Java app or application needs to be written within a class. I will explain what it is. And the file name and class name must be the same. For example, if you place your code in a class called test with capital T, then the file name must be test.java with capital T. Java is a case-sensitive language. Here is what I'm trying to say. Everything that you write should be between this left and right braces. So your code will be inside right here, inside a class called test. If the name of the class is test with capital T, your file name should be what? Test.java. This is a simple text editor. This example is in Mac OS, so this is text edit. but it could have been Notepad in Windows operating system or any other text editor. I repeat, everything needs to be written in a class, and then the name of the file should match to the name of the class. Well, for Java applications, there must be a special method called main method. And naming the method main is not sufficient. You must define it in a specific way. And the main method will be fully clear to you in the upcoming lectures. But right now, all you need to know is that if you want to start with any Java application, you have to have those 4 lines. You must have your class test, left and right braces, and you must have a method called main, and it must be defined just like this: public, static, void, main, and then parentheses here, and string with capital S, and arcs with square brackets, and then left and right brace. So what is special about main method? When we run a Java application, Java needs to have a starting point. In other words, Java needs to know where to go and start interpreting the program. So the main method is the entry point. So if you have a main method defined just like this, the starting point for Java to run will be the first line inside your main method. But if you don't have a main method, Java will get confused and it will not know where to start executing your program. Therefore, main method is crucial. For example, instead of this string here, if you have something else, that's not the main method. It's a main method, but it's not the main method Java is looking for. If you don't have static here, that's not the main method. It must be static because Java will be looking for this kind of declaration. You don't understand what public is, static, void, string, those square brackets, that's perfectly okay. That's the goal of this class. You're going to be expert on all those concepts real soon. So here is the first simple program. Again, I name it test, the class, and the file name is test.java. It matches exactly the same as class name. I have public, static, void, main method. Inside, I have something called system.out.println. Do not worry about system.out yet, but println is a method which takes a string as input. I say string, anything between double quotes is a string data type. So println is going to print hello TSU students on the command prompt or terminal, depending on your operating system, and the cursor will go to next line. ln stands for line. In other words, if I go and type javac test.java, remember this was to compile this program. If there are no errors, it's going to create a file called test.class, and then you're going to go and type java test, and when you say java test, Java will say, okay, do I have a main method inside class test? Yes, I do. Then it will go to the first line of the main method, and it will see println. It say, okay, I have a method called println, so it's going to print hello TSU students on the command prompt. And because of this ln, the cursor will go to the next line. It's pretty simple. I just do it again in a different way. Here is the starting point. When you open the text editor, this is the first thing you're going to type: public class test. Common convention in Java, class name starts with capital letters. You don't have to do it, but as a good programmer, you should follow the common conventions. So class name should start with what? Capital letters. Then you should immediately put public, static, void, main, parentheses, string with capital S, arcs, and square brackets, and then left and right brace. And then you start writing your program, system.out.println, in this case, hello TSU students. Pay attention, we need to be organized. And for example, if you have left brace, right brace in this level, you should have a tab and put your main method in the second level. You should have another tab inside your main method and put your content in the same level. Otherwise, it's going to get confusing later unless you follow those good guidelines for writing programs. Here's another example. Again, public class test, left and right brace, and then public static void main string. By the way, those square brackets refers to an array, and arrays are going to be subject of, I believe, lecture 5. So this is nothing but a string array. And then I have left and right braces. This time I have two println function calls. The first one is hello. So on the screen or on the terminal, I'm going to see hello, and ln means next line. Then the cursor will go to next line, and then I will see TSU students. Here's how I compile. I type Java C. Remember, C stands for compile, space, test.java. And then in order to run it, I type Java test. As soon as I do that, Java is going to look for what? Main method. It will go to the first line. The first line says println hello. That means print hello and go to the next line. It prints hello, goes to the next line. Then prints TSU students and goes to the next line. TSU students and cursor goes to the next line. Here is the same. I mean, something similar. I know I'm repeating myself, but I'm doing this on purpose so that you feel that those steps are pretty much automatic for you to do in order to write any program. You type public class test or any name that you want to give to your program, left and right braces, public static void main, a string array as input to the main method, and then you go inside. This time there's a little difference. Instead of println, I have print. The difference between print and println methods is that when you use print method, cursor stays. For example, it prints hello, and cursor goes right after letter O, and it stays there. But when you do println, cursor goes to the next line. So here it is. I compile Java C space test.java, and then I run Java test. First, it says hello, cursor is right after O, right there, and then it prints TSU students. Notice that I don't have any space here, therefore I don't have any space right there. However, I could have the same thing. I could put a little space here, then it will do what? Hello, space, TSU students. So difference between print and println, cursor stays at the end for print. For println, cursor goes to the next line. All right, again, public class test, left and right braces, public static void main, a string array as input. And then this time I have something else. Well, print, and then print method takes double quotes. That means that's a string. When you have a string, Java is going to try to first, okay, it's going to print hello. As soon as it sees a backward slash has a special meaning in Java. It will look for the next character, and it will take backward slash n as together as a kind of directive for Java. That means next line. It will print hello, it will go to the next line and type TSU students. But pay attention, this is print, not println, so cursor will stay right after S. As you see here, it prints hello, goes to next line, types TSU students, and then the cursor stays right there and says, how about this one? This time I have println, it will print hello, next line, TSU students, and next line because of this, ln. I compile Java C space test.java. I run Java space test, hello, next line, TSU students, next line. How about this one? This is pretty easy. It will print hello, it will go to next line, print TSU, next line, students. So hello, TSU students. Why do I have next line after students? Because of this ln. Why do I have space after? Why do I go to next line after hello? Because of this n. And the reason that I go to next line before students is this backward slash n. So Okay, as good programmers, you just don't write your program. You put a lot of comments. Comments make your program readable. For example, what's the purpose of the program? Should come to the top, maybe the first couple of lines. If you define a method, you should tell the reader of your program what that method is about. If you define a variable, maybe you should clarify the reason that you defined that variable and things like that. So as a good programmer, don't be shy to put a lot of comments. Comments are important and they improve readability of your program. And comments are simply ignored by Java. So, I mean, Java will not execute your comments. There are two different styles for comments. One is C++ style. In C++ style, you use double forward slashes. When you have double forward slashes, that line, anything after double forward slash in that particular line will be commented out. That means Java will ignore those. And also C style comments, they are backward slash star and forward slash star and star forward slash. Anything between those two, that block will be commented out. Let's see an example. Here is C++ style commands. For example, I have forward slash. This is our first example program. Next line, forward slash TSU students. So this is just simply commands that we put. They are going to be ignored by Java. I could have done exactly the same thing this way, forward slash star forward slash, and anything between them will be ignored. Okay, escape characters. Backward slash n in that string was an escape character. It meant new line. But there are some other characters that we use. For example, backward slash t tells Java that it should give a horizontal tab size space between two words. Or backward slash r is called carriage return. It positions the cursor to the beginning of line. Let's see with examples. Let's look at this. Again, forward slash example program. And I have hello. This is println. It will print hello. Backward slash, as soon as it sees backward slash, it will look for the next character. Backward slash t. What does that mean? That means tab. So it's going to leave a tab space. Then TSU, it will see another backward slash. It will look for the next letter, backward slash t. It's another tab. So here's what you're going to see. You compile java ctest.java, you run java test, you have hello, tab, TSU, tab, students. And then the cursor goes to the next line because of this ln. How about this one? I want to give you like a couple of seconds to think. This is pretty easy. It will print hello, then it will have a tab space, TSU. It will go to the next line, print students, and then it's going to give two extra lines, and the cursor will go to the third line. Here, hello, tab space, TSU, next line, students, and then two lines, and the cursor goes to what? Third line because of this ln. Pretty easy. Okay, let's see this one. It says hello, backward slash r TSU. Let's see what it prints. It prints TSU LO, but why? First, we have hello. As soon as it prints hello, cursor is right after letter O. But when I see backward slash, I look for the next letter, backward slash R, carriage return. It tells the cursor should go back to the beginning. That means cursor should go to the level that the letter H is. And then it has TSU starting from this, and T will replace H, S will replace E, U will replace L. And then you will see TSULO. Another example, I have hello, backward slash R, students. Well, when I run this, I see only students. Why? Because I have hello, I have students. Sorry, yeah, hold on. I have hello, I have students. After hello, the cursor was here. As soon as we have backward slash R, cursor came all the way back to letter H, and S will replace H, T will replace E, U replaces L, V replaces L, E replaces O. Therefore, I see students. So /n is new line, /t is tab, /r is carriage return. It takes the cursor to the beginning of the line. Okay, so what is a class? That's what we really need to understand. I was trying to give this example, but let's do it more official. Think about the Batman building in Nashville. That's the AT&T building you can see from everywhere. My question to you is, can we have the exact replica of Batman building in Memphis? Can I have exactly the same building? Can I have exactly the same building in Atlanta, New York City, Chicago? Of course I can, right? But what do I need to do in order to do that? All I need to do is what? To have the blueprint of the Batman building. As long as I have that blueprint, I can use the same blueprint to build different buildings in different cities. The blueprint that I refer to is a class, and each Batman building is an object. So using the same blueprint, you can create as many objects as you want. Here's another way of looking at it. That's the blueprint. And using the same blueprint, I have the Batman building in Nashville. I have the Batman building in Memphis. I have the Batman building in Atlanta. And the blueprint is the class, and each one of those buildings is an object created using that class. Java is an object-oriented programming language. In other words, everything is blueprint-based. You first create a blueprint, and then you create objects from that blueprint. I just wanted to make it simple. I hope you understand at very high level. In the upcoming lectures, we are going to see how we can create a class. What are the components of a typical class? We'll talk about constructors, data, methods, and so on. We are going to see how we can use new keyword to create and allocate memory spaces for objects. So hang in there. These are going to come in time. Okay, so let's talk about common conventions. This is a very simple program. The common convention in Java is class names start with uppercase letters. So my question to you, in this simple 4-line code, how many classes do you see? Just think about a second. Remember, they should start with uppercase letters. I can see one right there, test. T is capital. Well, that's a class. I can see another one, string. S is capital, string is a class. System starts with capital S, so that must be a class too. So there are 3 classes in this simple program. The first class, test, is our user-defined class. But there are 2 other classes, string and system. These are the classes we did not develop, but yet we are able to use it. So my question to you, who defined string and system? Where are they located, and how am I able to use them? The answer is pretty simple. I'm going to talk about Java API. I am sure you heard API keyword. API stands for Application Programming Interface. Java API is Java Application Programming Interface. And Java API is nothing but predefined classes for you by Java developers. Once Java was developed, Java developers defined more than 1,500 classes for us to be readily used. But when they developed those classes, they placed them in different packages so that relevant or related classes are in a package, some other related classes are in another package, and so on. For example, classes related to GUIs or graphical interfaces are placed in one package. Classes that provide some utilities are placed in another package. Okay, so Java API is nothing but predefined classes that are available to us, and classes are located in packages. There are 2 groups of packages. The packages starting with Java are called core packages. Packages starting with Java X are called extension packages. The reason is very simple. Once Java was originally developed, we had original packages, but as Java progressed with newer versions, some extensions, some other packages were added, and they are called extension packages. So the first package that you must know by heart is java.lang package. As you guess, lang stands for language, java.lang package. This is called default package. The reason that it is called default package, java.lang package is automatically imported into all Java programs. You don't need to explicitly import it. Whenever you have a Java program, boom, Java adds java.lang package for you so that all the classes in that package are available at your disposal. And as you guess, system and string classes are from java.lang package. Therefore, I was just able to use what? System and string packages without importing any package. They were already there. I just used them. And there are some other useful classes in that package. In addition to system, string, we have math class, integer class, double class. Note that the class names all starts with what? Capital letters, system, string, capital M for math, capital I for integer, capital D for double. Later, we are gonna see that we also have something called int with lowercase I. That's a primitive data type. Integer, however, is a class. They are called wrapper classes. For example, integer with capital I, double with capital D, even though we have primitive data types, int and double, these are like classes. They are called wrapper classes that provide some extra functionalities for us to deal with some primitive data types. We are going to learn about them later. I'm just telling you that you don't get confused with integer with capital I and int with lowercase I. They are two different things. So again, java.lang package is the default package. It has very useful classes. Since those classes are very, very commonly used in almost all Java programs, they are placed in a default package so that it automatically imports, Java automatically imports them into your program. You don't have to explicitly import them. And system and string were coming from those java.lang package. If we go back here, string and system, they are in java.lang package. It's automatically imported, so therefore I am able to use them without any problem. Another package, javax.swing. By the way, the java.lang package starts with Java. That means that's a core package. However, javax.swing package starts with javax. Therefore, that's an extension package. That means it was developed a little later. javax.swing package contains many graphical user interface classes. For example, if you want to write a program that shows a message box, or if you want to get input from a message box, instead of going to terminal or command prompt app, which seems very primitive, you can have a message box and, and have a simple graphical user interface. Then you use JOption pane class. Text field, JText field, button, JButton, JCheckbox, JLabel, JScrollbar, and so on, okay? I'm sure you understand here another concept. If your class has multiple words, for example, option, pane, O is capital, P is also capital. If you have multiple words, second one always starts with a capital letter, okay? Well, javax.swing is not the default package, so it will not be automatically imported for you. If you want to use JButton, for example, somehow you have to import this package, and I'm going to show you how to import with an example very soon. Another package, java.util. Util stands for utilities. Since it starts with Java, that's a core package, obviously. It contains many utility classes, and today in this lecture, we are going to use one of them called scanner class. For example, if you want to read input from a console or terminal, you will need to use scanner class. For example, if you have a program that asks you to enter some numbers, in order to read what the user entered on the terminal or command prompt, you will need to use scanner class. But there are other useful classes like date, calendar, currency, locale, timer, and some others. Of course, again, this is not the default package. Therefore, if you want to use any of those classes, you will have to explicitly import java.util package, all the package or particular classes from the package. I will show you how to do that. Let's continue with common convention. We already know by now that test is a class because it has capital letter, system is a class, S is capital, string is a class because S is capital. Common convention for methods, method names start with lowercase letters. And in order to distinguish a method, methods must have parentheses. If you are defining a method, you must have a parenthesis to define it, or if you are calling a method, you must have a parenthesis. And method name starts with lowercase. For example, main is a method. How do I understand it's a method? Because I have a parenthesis here, opening and closing. And main method, as you see, M is lowercase because that's the common convention for methods. Another method I see is println. How do I know that's a method? Because of parentheses right there, right there. The difference is main method, we are defining our main method here. This is called declaration of the main method. We declare main method right there. However, for this one, we are calling println method. We are not declaring it. Somebody else already developed this method for us, and we are just calling that method. Again, P is what? Lowercase. They are defined and called with parentheses. Access identifiers. Okay, so far what do we know? Test is a class because T is capital. System is a class because S is capital. String is a class because S is capital. Main is a method because I have parentheses. Println is a method because I have parentheses. And main method starts with lowercase, println starts with lowercase, okay? Out is not a method, for example. Why? Because I don't have parentheses after that, okay? And there are two public keywords here. They are called access identifiers. In other words, my class test is public, my method main is public. You don't know what they are. There are other access identifiers such as private, protected, none, or public. We are going to talk about them, but as you can guess, access identifiers have a lot to do with who can access to your class or who can access to your method. When you make it public, it is more accessible. When you make it private, it is least accessible. When you do protected, well, it is between. We are going to learn about those in time. So all I want you to do is that you should be able to identify an access identifier. Private, public, protected. And we'll talk about them later. So when I look at this example, I see a class, name test, T is capital, and the class is public. I see a method main, that method is public. That's all what you need to know here. Well, identifiers, anything that you name in Java is an identifier. For example, if you have a variable, if the name of that variable is an identifier for you, the name of methods, classes, interfaces. Later you're going to see that there are different kinds of classes. Maybe there are abstract classes, and there are interfaces. Interfaces are special type of classes. Don't get confused. So the name of variables, methods, classes, interfaces, and packages, they are all called identifiers. For example, here, test is the name of the class. Main is the name of a method. System is the name of a class. Println is the name of a method. Out is the name of an object. We will see later. I don't expect that you understand this at all. String is the name of a class. Args is the name of a variable. So, well, when you define identifiers in Java, you cannot just name anything. There are certain rules that you have to follow. Identifiers must be composed of letters, digits, underscore, or any currency symbol. But if it has a digit in it, it cannot start with digit. So let's see an example. All of those identifiers are valid in Java. Why? This is all letters. This is all letters. This is a single letter. It's a single letter. Underscore, as you see, I can have underscore, and underscore can be the first thing, no problem. Underscore letter, underscore letters, letters, digits, letters, that's perfectly okay. Underscore, digits, letters, letters, dollar sign, letters, dollar sign, letters, dollar sign, underscore, letter, no problem. But these are invalid. For example, you can have x3, but you cannot have 3x because your identifiers cannot start with digits. This is not valid because you have what? Space. This is not valid because you have something other than what? Dollar, a currency symbol. Again, you have something other than currency symbol. Plus sign is not allowed. Here you have something other than currency symbol. Backwards forward slash is not valid. You have dash. Dash is not allowed. You can have underscore, but not dash. Again, 45, it cannot start with digits. Again, it cannot start with digits. In addition to those rules, there are certain keywords, they are reserved in Java. For example, so far here, public is a reserved keyword, so you cannot name your variables public. Class is a reserved keyword. Let's see, string is a reserved keyword. You cannot use reserved keywords in Java, and you cannot name them. You cannot name your identifiers with those. Let's see a brief list. Here, get familiar with some of them. Let's see what we have seen. I said private, protected. Let's see, static, for example, right there. Okay. And public right there. So any one of those keywords are currently used by Java, and you cannot name your identifiers with any one of them. There are other keywords. They are not currently in use Java, but they are typically used in other programming languages. For example, const is a keyword in another programming language. Java has final instead of const, but still, you know, Java preferred to reserve those keywords so that you cannot use them. For example, goto is a concept from basic programming language. And also there are reserved literals in Java, true, false, null. And we will talk about them too. So you cannot use any one of those identifiers. To sum up, they are composed of letters, digits, underscore, or any currency symbol. They cannot start with digits, and they cannot have any one of those keywords as identifiers. You cannot have them. So I hope so far it is clear. Now we are gonna do something little complex. You will not fully understand some lines, but that's perfectly okay. We are gonna start using scanner class. If you recall, I said that scanner class is in java.util package. Well, java.util is not the default package. Therefore, if I want to use scanner class from this package, I have to import it explicitly to my program. And scanner class have a lot of useful methods. Well, 4 of them that we are going to use today. Next int, pay attention, n is lowercase because method name starts with lower cases. And if you have multiple words, the second one starts with capital letter. So I is capital. Similarly, n is lowercase, d is capital, lowercase, capital, single word starts with lowercase, and methods have parentheses. Okay. So here is the example. Let's take a look at that. I'll give you 10 seconds to look. All right. So I said that I'm going to use scanner class. I know scanner class is located in what package? Java.util package. Since this is not implicitly imported for me, I explicitly imported using import keyword. The first line I go to the top, I type import java.util.scanner. Now Java knows that I'm going to be using a class called scanner, and Java also knows where scanner is located. It is located in java.util package. Then I have public class test, left brace, right brace. I have public, static, void, main, parentheses, a string array, left brace, and right brace. And when I compile Java C test.java, I run it, the program will show a line, enter an integer, double columns, and then the cursor will wait there. I type 5, for example, and the program says you entered 5. How? So what do I do here? First, I add scanner class using import keyword. After that, I create a scanner object. Well, you don't know those concepts, but it's pretty easy. When I say scanner scan, I immediately say that scan is gonna be a reference to scanner class. But also when I use new keyword, in Java, new keyword is used to allocate memory space. So I create an object called scan, whose type is scanner. Don't worry about this part, okay? Since I have the new keyword, that means I allocate memory space for this object. So scanner was the blueprint. Using that blueprint, I created an object and I called it scan. Then after I compile and run, Java will go to what? To the main method. It will execute the first line. So the first line is creating an object called scan, whose type is scanner. That's all what you need to know. Then an empty line, and then it will go to this line. It will say enter an integer. Bam, I see here enter an integer. And cursor is there. Why? Because I don't have ln. Cursor stays right there. Then I type 5. Then I define a variable whose type is int. Int is a primitive data type. We'll discuss it. And I name that variable input. So whatever I typed is gonna be read by object scan using method next int. Because what I typed is an int. I know that I'm going to type an int. It asks me to enter an integer. Then I tell Java, go there and read whatever the user typed as an integer and put it in a variable called input. So now input is equivalent to 5. Then it will go here, println. It look for double quotes. It says you entered, and then 5 plus 5 means first take 5, convert to an integer, and concatenate it or append it to the previous string. This is the string. This is an integer. Java will first convert this integer to string and add it. In other words, append it to what? To this string. So you will see you entered 5. Nothing to get confused here. Let's look at again. I created a scanner class. I imported scanner class. I created a scanner object, and system.out.print prints enter an integer, cursor waits there. You type 10, 15, whatever. In this case, in this example, I type 5. And then whatever you typed is read by next int method of scan. And scan is a scanner object. In other words, next int must be a method of scanner class. Because next int is called via an object whose type is scanner. And it reads whatever I typed here as an integer, place it into input variable, and then when I refer to input variable here, I meant the value of that input variable, which is 5. 5 is converted to a string and appended into what? This string between double quotes. Here's another example. Let's look at this. Sorry. Okay, first, I go and import scanner class. Why do I import this? Because I'm going to use it. Why do I have to import it? Because Java doesn't know what scanner class is, because it's not in the default package, java.lang package. And it is located under java.util package. Then I have the main method. I define 3 variables, I1, I2, I3, and their types are all integer. I create a scanner object, scanner space, the name of the object, equal to new scanner, and in parentheses, I have something system.in. You will not understand this at this point. Do not worry about it. All you need to know is that I created an object named scan whose type is scanner. Then I say system.out.println and enter 3 integers. I say enter 3 integers. In this example, I enter 45, space 32, space 34. And the first integer will be read by this one, this function call. So I1 will be 45, I2 will be 32, I3 will be 34. Then I go here, I say you entered plus I1 plus. Those pluses are not mathematical pluses. This is string concatenation operator. So you have a string. I1 was 45. I1 will be converted to string and appended to this. Then I will append a comma and space. See, a comma and space. Then I will get I2, which is 32, converted to a string and appended. 32, and then I will have comma and space. I have comma and space, and then I will get I3, which was 34. I will convert it to string and append it. Then it says you entered 45, 32, 34. So here is a question for you. How many classes do you see in this example? I can see scanner is a class. Why? S is capital. Test is a class, T is capital. String is a class, S is capital. Scanner, I already said that's a class. Or here it is, system is a class. I use system here, system here. So how many methods do we see? Main is a method because I have parentheses here, and I'm declaring or defining this main method here, okay? Print is a method. I have parentheses. I am calling print method here. Next int is a method. I have parentheses, and I'm calling next int method. And next int is a method of scanner class. How do I know that? Because I'm calling next int via an object called scan, and scan is type of scanner. Therefore, next int is an object, a method of scanner class. Here's another example. Well, let's see what this does. I imported java.util scanner. Again, I'm going to use scanner class, and it's located in java.util package. I know I'm repeating myself, but there's a purpose for that. I want to make sure that it's emphasized multiple times so that you can, understand better. Import scanner class from java.util package, public class test, left and right braces, public static void main, a string array, left and right braces, and the first line in the main method. Int I. I define a variable called I, whose type is int. It can have integers like 1, 2, 3, 4, -10, but it cannot have 1.5, for example. 1.5 is not an integer. Then I create an object of scanner class. I call it scan. How do I know I create? I use the new keyword. New keyword allocates memory space for this object. Then I will say system.out.println, enter an integer. Cursor will stay there. Here you go. Enter an integer. Cursor stays here. Then I type 45. And I will be equivalent to 45. You see that? Because next int is going to go after cursor and read the first integer that is typed there, which is 45. Then I have this append operator plus. Why is it append? Because there's a string here, and you are trying to add an integer to string. You cannot do that. Java is going to first convert that integer, 45, to a string and concatenate it to this string. So you will see you entered 45. You see the difference between previous and this one? I define the variable at the top, and whatever is read, I assign to that variable right there. Okay, so what happens if it says enter an integer, but I don't type an integer. I type 35.5, 34.5. Java will try to read it, but using next int method. But next int method will not be able to read it because it is not an integer, and your program will crash. Java is going to throw an exception. An exception is an indication of an error that program cannot handle. Okay? Exception handling is one of the topics, I believe, lecture 12. So we are going to learn about exception handling. All you need to know is at this point, well, next int method can only read integers. If you type something, if you type hello, hello is not an integer. It will not be able to read it and your program will crash. If you type a double, 34.5, it will crash. Okay? Here's an example. Again, I import scanner class located in java.util package. I define my class test left and right braces. I define my main method left and right braces. This time I define two primitive data types in two variables whose types are int and double. I can hold integers, D can hold double. And double is like floating point numbers. 11.33 is a double. 35 is an int, okay? And then I create a scanner object and I say enter an integer. Here, enter an integer. I type 34. Is that an integer? Yes, then I will have 34. I say enter a double, 56.7. This time, instead of next int method, I'm gonna read it with what? Next double. Okay, next double is programmed to read double numbers. Is 56.7 double? Yes. Then D will hold double. And then, sorry, D will hold 56.7. You entered plus, well, you have a string and plus. That means I will be converted to string first. 34 will be converted to string and it will be appended. So you entered 34 and then I have plus this string, space and, and then there's another space right there. You see that? Space and another space. And then D is a double, it will be converted to string and it will be concatenated. So you will see you enter 35 and 56.7. How about this example? We import scanner class. Don't forget this, otherwise you will get an error, compile error. I have class left and right braces. I have my main method left and right braces. I define three variables whose type are double. So num1, num2, sum, they can all hold double numbers in them. I created a scanner object. This time I called it obj on purpose. I can name it anything. But if I named it obj, I must call next double via obj. In the previous one, I had scanner and next int was called via, scan. I called next int via scan. Whatever the name of the object, you must call your method via what? That object. Okay, so num1, num2, sum are double. I created a scanner object obj. I say enter two numbers. And then I read the first number. Look, print, that means the cursor is on the same line. It asks to enter two numbers. I have 23.5, 67.8, for example. Num1 will be 23.5, num2 will be 67.8, and then I add them up. If I add those two numbers, it is 91.3, and I assign 91.3 to sum. Then I say system.out.println, the sum is 91.3 will be converted to string and appended to this. I hope this is clear. Here is one more example. This time I'm not going to deal with numbers, but strings. So import scanner class, left and right braces in my class, left and right braces in my main method. This time I define a variable called name whose type is string. Okay, so name can hold string data. I created a scanner object. I say enter your name. I say enter your name. I type Ali Sekman. Whatever I type, next line reads the complete line. See, Ali space Sekman, right? it does not just read Ali, but it reads the whole line, Ali segment. And then it says your name is plus name. Name is Ali segment. That's a string already. It doesn't need to be converted to string. So this is a string, this is a string, plus sign means append those two strings together. Your name is Ali segment. I repeat, I imported scanner class, I defined a variable called name, I created a scanner object, I named it obj, I asked the user enter your name, cursor, because of print, cursor is right there, and I went to the terminal and I wrote Ali segment. Next line is a method of scanner class. How do I know? I call next line. First of all, how do I know next line is a method? Because of those parentheses. How do I know that next line is a method of scanner class? Because I call it via obj. And obj is a type of scanner object. Okay? And then here name will hold Ali segment as string. And then it will say your name is, because of the space, I will have that space right there, Ali segment. Here's another example. This time I define two strings, first name, last name. Okay? Let's see the difference between these two. I create a scanner object, I call it obj. It says enter your first name. Enter your first name. I type Ali and hit enter. So next line is gonna read Ali and assign it as first name. Then I have another print, enter your last name, and I type segment and hit return, and the segment will be read by next line and last name will be segment. Then I say your name is first name Ali, space right here, segment. Your name is this space here, is this space, Ali, and then right there space and segment here. All right, so I believe this is the last example with scanners, and the same thing. This time, in the previous example, I had two different lines, sorry. In this example, I had two different lines for first name and last name, but in this one, this time I use next, by the way, not next line. I define first name, last name. Pay attention, F is lowercase, N is capital. If I said before, if you have multiple words, the first one starts with lowercase, but the second, third, fourth, fifth, they start with uppercase letters, okay? Enter your first and last name, and I type Ali space segment. If I have next line, Ali segment is read all together. But if I want to read each one separately, I need to use next method. Then I say first name obj.next, it will read Ali, and then when I call next again, it will read segment. Then it says your name is Ali space segment. Well, I hope this is clear so far. And if I go too fast, just stop the video. And it's better that you also go and write your code while going over this video. So printf method. So far we used print and println. They were pretty good and easy. But there's another method, printf. And printf method is a very powerful method too. And I'm going to show this with example. Okay. So think about this. This is printf here. Again, system.out.println, and I have printf. Okay. So what printf method does is that inside the string that it is supposed to print, if you have a percentage sign like this, it looks for the next character. For example, percentage sign D, and I have another percentage sign D. D stands for digit in this case. So as soon as it sees percentage sign D, it goes after comma and gets the first integer and replace this one with that integer. And another percentage sign D, it goes after comma to second integer in this case. For example, the I1 is 20, I2 is 100, right? It will say the numbers are, as soon as I see percentage sign D, I will replace it with I1, which is 20. And this is second percentage sign D, so I will go to the second one, which is 100, and replace it with 100. I hope this is easy to understand. There are different versions of percentage sign D. For example, assume I have this integer I, 1,235,462. If I say printf, the number is percentage sign D, I go and get I, just as it is, okay? And then /n, remember, it was next line. So the cursor goes to next line. If I say percentage sign and then comma D, it prints it like in more professional format. It separates every 1,000 by a comma. I repeat, percentage sign D or percentage sign comma D. The difference between them, if it is percentage sign D, just an integer. And this is also the same integer, but every 1,000 is separated by a comma. You first have this, separated, separated, separated. If you say percentage sign, for example, comma 15, well, 15 means, yes, show it just like this, but make sure that you have 15 characters. That includes commas. For example, here, character 1, 2, 3, 4, 5, 6, 7, 8, 9, and then there are 6 empty spaces here. So total is 15 characters. Okay, very simple. Percentage sign D as it is, percentage sign comma, put a comma for every 1,000. And if you have a number before D, that's the number of characters that your integer will occupy when you put it on the terminal. Okay, same thing for doubles. For doubles, we put percentage sign F. F stands for floating, and floating point numbers. I repeat, here, percentage sign D for integers, percentage sign F for doubles. For example, 23.3456. If I say print this, the number is percentage sign F, it goes after comma, get number, and it prints just there. But pay attention, the default format is 6 digits after comma, after dot. So it adds 2 zeros right there, okay? And goes to the next line because of /n. Now it says 8.3. Well, this says I want to have 8 characters in representation, and I want to limit what I have after dot to 3 letters, 3 characters, or 3 digits. Think about this, 3, 4, 5, 6. 56 will be rounded up to 6. Then we will see 3, 4, 6. Why? Because of this dot 3. And 1 character, 2, 3, 4, 5, 6, 7, 8. 2 empty spaces. Why? Because of this 8 here. How about 8.2? Well, we're going to round up to 2 characters after that. Well, 3456 is rounded to clearly what? 35, because 56 is bigger than 50. So this is going to be what? 35. So 35, and how many? 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 3 empty spaces. It's going to be rounded to 1. 3456 is going to be rounded to what? 3, because 4 is less than 5. So 3, and how many characters I'm going to have? 8, right? 1, 2, 3, 4, including dots, by the way. 5, 6, 7, 8, 4 empty spaces. If I say dot 0, well, 23 point this will be approximated to 23 because 3 is less than 5. If this was 23.7, for example, it would have been 24. 23 and then 6 spaces. How about this comma? Well, comma, if I told you before, separates thousands, but 23 is not a big number. It is less than 20. It's less than 1,000, so nothing will do. This comma will not do anything special. How about if I have minus sign? Well, if I have minus sign, it's going to left align my digit. Okay, so here the default is right alignment, right? But here, when you have minus, it will left align. Let's have a better example with a very big number. So this is a big number. If I say %sign F, I will see that number, but again, the default is 6 digits after that, so it's gonna put 2 zeros. Here, 8.3. Well, in the previous example, 8 digits make sense. Why? Because I have 23.35 is less than 8 characters. So you have empty spaces here. But in this one, it makes no sense because your number has more than 8 digits. So, but I limit the numbers after dot to 3. So 35, 56, 5, 56 is bigger than 5. So this will be 3, 4, 6. 3, 4, 6. If I approximate to 2, it's gonna be 35. Why? Because after 4, I have 56, which is bigger than 50. If I do 1 digit, it will be 35. Sorry, it will be 3 because 4 is smaller than 5. If this was 37, it could have been what? 4. But now 34, 4 is less than 5. So it will be approximated to what? 3. 8.0, so nothing after that. Well, 3 is less than 5, so it will be just this number. How about if I put comma? In the previous one, comma didn't make any sense because we didn't have any thousands, but here we do. Like it's gonna put a comma here, a comma here, a comma here. How about left alignment? In this case, it's not gonna make a difference. I mean, because all those numbers, since they are bigger than 8 characters, they are all left aligned anyway. It seems confusing. I don't think you are gonna ever need, to memorize any one of them. Whenever you need to use them, you go back and, refresh your memory. So this is not something that you will memorize, okay? Well, also, we have %sign D for integers, %sign F for doubles, and we have %sign S for integers. S is for strings. I define 2 strings, S1, S2. S1 is Tennessee State, S2 is university. I say printf, the best university is %sign S, %sign S, back to back. So it will get the first %sign S. It will go and get S1, put Tennessee State. And then there's space here. You see that? Space, and get second one, university. So on the screen, you will see the best university is Tennessee State University. Nothing difficult, just %sign. Look at the next character. If it is %sign S, go get the first string. If it is %sign D, go get integer after comma. If %sign F, go get double after comma. Well, okay, so let's look at this and let's see why it is like that. I have S1, Tennessee State University. My university is not just %sign S, but %sign 20S. That means the length should be 20 characters. So I'm gonna write Tennessee State, but I wanna make sure that I have sufficient empty spaces here. Let's see, E is 1, 2, 3, 4, 5, 6, spaces 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That means I have 5 extra characters as empty spaces right there. Okay, so this is simple. I hope you spent a little bit of time to understand those. This is important, extremely important. You have to understand this. There are 2 kinds of data types in Java: primitive types, reference types. As data types, primitive types, reference types. And there are 2 kinds of data values that can be stored in variables. What do I mean by that? For example, int is a primitive data type. Double is a primitive data type. Look, I is lowercase, D is lowercase, okay? These are primitive types. However, string is a class because of S is capital, and this is called a reference type. Primitive data types and reference types. And then I have a primitive value. Num1 is a variable that can hold a primitive data type in it. We call it primitive value. Num2 is also primitive value. However, first name, last name, they are what? Reference values. I repeat, this is crucial. Int and double are primitive data types. String is a reference data type. Num1 is a primitive value. Num2 is a primitive value. First name and last name are reference values. Actually, primitive data types, these concepts are very, very easy. Let's see. Primitive data types. First, they are categorized into two, Boolean type and numeric types. And Boolean type is just Boolean. Boolean is a primitive data type. Boolean means, from Boolean logic, true or false. So Boolean variables can hold only true or false, one of those two values. Numeric values are further divided into integral types and floating point types. And integral types, floating point types are, we have only two, float and double. And integral types are further divided into character type and integer types. Character type is only char or char, whichever you call, okay? Char, let's say. Only one data type, primitive data char. Integer types, we have 4 of them, byte, short, int, long. So this tells us that we have 8 primitive data types: Boolean, char, byte, short, int, long, float, double. Okay, let's do this again. This is important. Primitive data types: Boolean type, numeric types. We have only one data type under Boolean category, that's Boolean. Numeric types, we have integral types, floating point types. Floating point types are float or double. Integral types are further divided as character type or integer types. Character type is char. Integer types are byte, short, int, or long. So we have 8 primitive data types. Anything else are reference types. So Boolean. Well, if it is just true or false, how many bits do you think I need to represent it? True is 0, true is 1, false is 0, 0, 1, 0, 1. That means with 1 bit, I can represent this, right? 0 corresponds to false, 1 corresponds to true. So Boolean data type requires only 1 bit in your computer to store the primitive value for data type. That's easy. Characters. Characters are represented by 2 bytes. Each byte is 8 bits, right? So you need 16 bits to represent a character value. Byte, you need a byte. Name says that. A byte is represented by 8 bits. Short values are represented by 16 bits. Int values are represented by 32 bits. Long values are represented by 64 bits. And then float, 32 bits, double, 64 bits. Well, you don't have to memorize, but you should think that, hey, byte should occupy less space than short, short should occupy less space than int, int less space than what? Long. But let's check this a little bit in more detail. Byte, 8 bits. With 8 bits, you can represent 256 numbers. 2 to the 8 is 256. The range of byte is from -128 to +127. So the range is from -128 to +127. That are, including 0, there are 256 numbers. Short, with 16 bits, the range of short values is from -32,768 to +32,767. Of course, you don't have to memorize, but look at this. All the bytes are in the range of short. So all the bytes are included in short. Then char or char. Look, short is 16 bits, represented by 16 bits. Char is represented by 16 bits. However, short includes negative numbers as well, from negative 32,000 something to positive 32,000 something. However, char includes only non-negative numbers. It starts from 0 all the way to 65,000 something. So some of the shorts are char, some of the chars are short, but there are certain short which are not character, and certain characters are not short. For example, 40,000 is not in the range of short, but it's in the range of what? Character. Or negative 1,000 is not in the range of character, but it's in the range of short. For byte, we know all the bytes are in the short. But there are certain bytes, they may not be in character, right? Because there are some negative numbers. So it's clear that byte and short have direct relationship, but byte and character or short and character, they don't have direct relationship. How about integer? Well, integer goes from negative this number to positive this number. It's clear that byte is in the range of integer. Short is in the range of integer. Char is in the range of integers. So we can always say byte is an int. Short is an int. Char is an int. Or we can say byte is a short. Short is an int. But I cannot say byte is a character or char, because there are certain bytes, they are not in char. I cannot say short is char. I cannot do that. How about long? Long is 64 bits. Longs, the range is from this number to this number. Clearly, long includes all of them. So this is one way to think about it. A byte is a short. Why? Because this range is within this range. Short is an int. Why? Because the range of short is within the range of integers. And int is a long. Why? The range of integer is within the range of long. So you can always have this way. Byte is a short, short is an int is a long. Or byte is a long, short is a long, byte is an int. You know, but you cannot say opposite. You cannot say long is an int, because range of long is much larger than range of integers. So you cannot say long is an int, or you cannot say int is a byte, int is a short. You cannot say short is a byte. Okay, so this is one direction. There's another one, characters. As you see, all the characters are in the range of int. So a character is an int, and I know int is a long. So there are like two threads. One is from byte to long, the other one is from char to long. I hope this makes sense, because we are gonna, there are a lot of little things that you may think it should be obvious, but it is not very obvious in Java. And some examples are gonna be surprising you a little bit later. So I just repeat, there are 8 primitive data types, and depending on the range I put here, you can think that byte is a short, short is an int is a long. Char is an int is a long. But you cannot say byte is a short. Why? Because there are negative numbers, they are not in character. Or you cannot say short is char. Why? Because there are certain numbers, they are not in char. Or you cannot say char is short, because there are some numbers, bigger positive numbers in character, like 50,000, which is not in the range of short, not in the range of byte. So there is no conversion between char and short, or byte and char. Well, I'm going to include also float and double. I'm not going to go into very details of this, but you must know that a byte is a short, short is an int is a long is a float is a double. Again, byte is a short is an int is a long is float is double. But short is not always byte. See, you cannot just say short is byte. Int is not short, long is not int. Sometimes it is, because you know some of the values in short might be in the range of byte, but not necessarily all the time. Again, float is not necessarily long, double is not necessarily float. And similarly, the other pathway. Car is int. Int is long. Long is float. Float is double. Int is not always car. Long is not always int. Float is not always long. Double is not always float. By the way, integral values, remember integral values were byte, short, int, or long. The default value for integral values is what? 0, or int, sorry. And floating point numbers, remember they were float and double. Floating point values are double by default. Let's see an example what I mean by that. Okay, so this seems so simple, but we have to be careful. Look at this, int I20. I define an integer, I call it I. I is primitive value. It holds int data type, 20. Then short s, s is short. The type of s is short. Now I'm assigning an integer to a short. Can I do that? Is an int a short? Can I assign an integer to a short? Let's recall, well, short is an int, but int is not necessarily short, right? Sorry, this keynote is a little bit inefficient. Okay, so this will be an error. And when you try to compile, Java C test Java, remember compile means checking the syntax, right? Well, it will check the syntax. Syntax says that I will be assigned to s. The type of I is int. The type of s is short. So I'm trying to assign an int to short. Java will complain. And it says possible lossy conversion. Yes, so it will not compile. And you will get a compile error. How about this one? Well, int I20. By default, I told you that integral types are by default int. When I say long L is equal to 20, this 20 by default is int. But I know that an int is a long. So it's perfectly okay to assign an int to a long, an int to an int. So there is no problems here. I repeat, 20 is an integral type. By default, it is considered as an int. I can assign an int to an int. I can assign an int to a long, no problem. Well, how can I solve this problem right here? Well, int I20. Now, here, I'm trying to assign int to short. Java will complain. Java will say, well, you cannot do it. But what if I insist? What if I say, yes, I know an int is not a short, but I take my chances. I want to make sure that you accept this. Then you have to do it explicitly by typecasting. You say here, hey, I is an int, but I want you to accept it as a short. If I lose something, I take the risk. Okay? So this is called typecasting. In this case, Java will not complain. You will be fine. It will compile. Okay? But assume this was not 20, but this was a very, very big number, which is bigger than the range of short. Well, then you may have some unexpected results. Okay? So you are taking a risk. But 20 is in the range of short. So in this case, you are not going to lose anything. You will be fine. Okay? I repeat, integer cannot be assigned to short, but you can explicitly tell Java, hey, I'm aware I cannot do it, but I still want to do it. Then you do it what? Typecasting. Okay, now let's look at this example. Let's spend a little bit time and let's see what does implicit widening and casting means. Here, int I20. Okay? Then I say long L 500. 500 is int by default. 500 is an integral type. By default, that's int. And I know that int is a long. So this is called explicit widening because Java will take 500 as int, it will widen it, it will convert it to long. That's called implicit widening. And Java will do it implicitly for you behind the scenes, and this will be perfectly okay because an integer can be a long. Okay? Or here integer I is 20 and I assign I to L2, which is long. Well, an integer to long. That means Java will first get integer, which was 32 bits, and it represented with 64 bits. You don't lose anything, but representation this time will have 64 bits. And it's called implicit widening, and it will assign it to L2. This is also okay. Remember, long is double. So now I'm trying to assign L to D. Can I do that? Yes, I can do it because long is a double. What does Java do? Java does implicit widening. It takes the long and represents it as double. So this is fine. Remember, when I say float f is equal to 34.6, remember floating point data types are by default double. So 34.6 is by default double, but double is not a float. So I cannot assign this double to float. I will get an error, okay? However, there are different ways to explicitly tell Java, I'm aware it may not be float, but I want you to accept this float. If I put a lowercase f or uppercase f, or if I do this way, this is called explicit casting. You say 34.6 is not a float, but I still want Java to accept it as a floating point number, just like here. This is called explicit casting. How about this one? Short s is equal to I. Well, I was integer. I am trying to assign I to short. I cannot do that. That's an error. However, I can do explicit casting like this. And I can force I to be accepted as short. Well, this is very interesting. I mean, I know Java does some unexpected stuff. Byte b is equal to 34. Previously, I said that 34 is an int, and int is not a byte. Well, if you do this way, if you assign I to s, you will get an error. But if you assign a number, which is in the range of byte, what was the range of byte? Negative 128 to 1, positive 127. 34 is in the range of what? Byte. So this is perfectly okay. Java will say okay. However, if you try to put 340, which is not in the range of byte, Java will complain, hey, you cannot do it. But if I say 340, which is an int, not in the range of byte, I put byte in front of it in parentheses, I tell Java, I know that's not a byte, but I take my risk, okay? I want you to consider 340 as a byte. But of course, since it is not in the range of byte, it will use an algorithm behind the scenes, and it will convert 340 to a number between negative 128 and positive 127. You may not like it, so you have to be careful here. How about here? Byte b s1. S1 was short, right? Short. Is short a byte? No. So that's an error. However, you can say, I'm aware S1 is a short, B1 is a byte. I cannot assign a short to a byte, but I want to take the risk. I want to do explicit casting right here. So from this point on, S1 will be considered as what? Byte, and called B1 in this case. Well, car or char, C is equal to I. I is an int. I know that a character is an int, but int is not necessarily a character. So this is an error. However, I can again do explicit casting, and I can force Java to accept I as character. How about here? C is equal to C. Can I assign a character to short? Remember, there were two lines: byte, short, int, long, car, int, long. We cannot switch between car and short or car and byte. So here, this will be an error. But again, you may say, hey, C is car, I know character, I know it's not a short, but I want Java to accept is short. So that's called explicit casting. Well, that's all I have here. But before I let you go, I may want to do a simple example with you so that just to refresh your memory about how to write a program and compile it and run it. It's pretty simple. Let's go ahead and do it. And let's go ahead and do it. I'm going to first bring terminal. Terminal is here. Okay, let's do this. Sorry, I'm just trying to. Okay. All right, so here is the terminal. This is command line interface. Remember, I said we should work in a proper folder. Let's assume that we are working in, and let's delete whatever we had before here. Okay, let's delete this one too, sorry. Okay, so I have the learning folder. This is my graphical user interface. I wanna switch there with command line interface. So this is my command line interface right here. If I say ls, it is pretty clear. Let's also clear this screen. ls, nothing is there. As you see, nothing is there. Then I need to go to text edit. I'm using Mac, by the way. If you are using Windows, what do you need to do? Instead of terminal, you should bring up command prompt app. This is terminal app. In your case, you bring command prompt app. And now I bring text edit. If you are in Windows, you need to bring what? Notepad. And let's go ahead and type public class test. Remember, I said always have this. Public class test, T is capital. And then the next thing is always a what? Public static void main, and then a string array. And left and right braces. As you see, there is no automatic indentation, nothing there. You just see your errors. This is a very simple primitive text editor. And let's go ahead and do this. For example, system.out.println. The first example. Okay, and then I save it. Let's go ahead and save it on the learning folder as test.java. As you see, it appears right there with the graphical interface. And if I say ls, it also comes here. That's it. Now I'm going to go and compile java c test.java. Well, remember, Java is going to now check the syntax. And if the syntax is correct, it's going to create a file called test.class. I do that. Syntax is correct. Boom, right here, I have test.class file. Now I'm going to run it. I say Java test. And when I do that, Java will immediately go and look for the main method. Public static void method. Do I have this method? Yes. It will go to the init and run the first line. This first example. Now let's pay attention. What if I forget this semicolon right there? And if I go with up and down arrows in the terminal or command prompt, if I compile again, it complains. Syntax is not correct. It cannot find a semicolon. So I'm going to go and correct it. Compile again. Fine. Run again. Fine. My question right now, I told you that the main method must be defined in a specific way, right? Assume that I didn't define it this way. Instead of void, later when you learn about methods, you're going to understand better. Let's have another data type, int. And let's compile it. Oh, sorry, when I put int, okay, let's go and also add return 0 or something. Don't worry about this if you don't understand. My point is totally different. So now I go and compile. It compiled. So I have a main method, but is it the main method? Is it the main method that Java is looking for? It is not, because Java was looking for main method called public static void, right? Now when I try to run it, you get an error. It says main method must return a value of type void. So you have the main method, it compiles, syntax is correct, but when you try to run it, Java is unable to find the main method it is looking for. But when you change this one back to void. And if you compile again, run again, you're fine. I'm going to tell you a couple of more things here. For example, here, instead of string, if I put, let's say, double. Again, now I have a method called main method, so it should just compile. But when I run it, it should complain because it doesn't have the main method. So I'm going to make it back to string. And now I'm going to compile again. I'm going to run again, no problem. How about here? I have public static. What about if I say static public? Let's see. If I do that, it compiles and run compiles. So public and static, you can interchange those. It can be public static or static public, doesn't matter, okay? But void must be right before main method. You cannot switch the location, okay? And some other ways, for example, here square brackets right there, you can also take them here, and it's going to be clear when we discuss arrays. Now if I go and compile and run, no problem, okay? So now let's write a program. Let's write a program together. And the program should ask two integers to be typed by the user. It should read them and then print the sum and product of those two numbers. How about that? Okay, so this is the structure that I should start with. Since I'm going to read something from terminal or command prompt, if you recall, I said that we have to have scanner class. So I'm going to import java.util.scanner. If I don't do that, I cannot, read anything from the command prompt or terminal. And then I'm going to create a scanner object. Scanner, let's call it TSU, is new scanner system .in. The reason I call it TSU, you can name it anything. It can be scan, obj, anything. So what I did, I imported scanner class. Why did I have to import? Because scanner is a class located in java.util package. Java.util package is not automatically imported in every program, so I have to explicitly import it. Okay. Well, then I created a scanner object. Now I'm going to define three variables. When you define your variables, the common practices you define on the top of your method. Within the method, main method, but on the top, I say int number 1, let's say, number 2, sum. In fact, I will also have product 4 because I said sum and product, right? So I define 4 integers. Now I'm going to go here. I say system.out.print, enter number 1. I say enter the first number. And now I'm going to read that number. I will say num1 is equal to TSU next int. Okay. So if I give some spaces just so that you can see better, I defined num1, num2, sum, product. They're all integers. I define a scanner object so that I can read what is typed on the command prompt or terminal. I say enter number 1. So whatever the user types is going to be read as number 1. Then I'm going to just copy this. Since this is a plain text editor, things are not that nice as you see. I will say number 2. And then I will read the second number. And then I will say sum is equal to num1 plus num2. And then product is equal to num1 times num2. Okay. So I ask the user to type number 1, number 2. I read them, I add them up, I multiply them. Now I need to display it back to the user, right? I can do system.out.println. I will do with 2 different ways so that you can see. I can say println, okay, sum is plus sum plus space plus space product is, okay, plus product is, okay, product is plus product. Okay, let's see. Let's go ahead and compile if we have any errors. It just compiled. We are lucky we don't have any errors. Now I'm going to go ahead and run it. Enter a number, let's say 20. Enter another number, let's say 12. It says sum is 32, product is 240. You see, sum is 32, and then I have this space, big space here. The big space here, product is 240. So this is string, this is int, first converted to string and appended to this. And then this is a string, product is an int, converted to string and appended to this. Or I could have used printf method, system.out.printf. Okay, I can say sum is person is signed D and product is person is signed D, and then I could comma sum comma product. Okay, so as soon as it sees person signed D, it will go after comma, get the first one. Second person signed D, it's going to go after comma, get the second one. So this should print more or less the same thing. Compile, run, enter the first number 30, second number 14, sum is 44, product is, and this space is larger than this space. That's the difference. Again, it's very, very easy. Very, very easy. For text edit, maybe I should change the size here to 18 so that you can see better. Let's close this. Let's bring it again. Oops. What did I change? Let's delete this. Okay, text edit, preferences. Sorry, instead of 9, I did, instead of 18, I did 9. Let's make it 18. Okay, so let's write another program. Let's write another program. I just want you to get familiar with this. The first thing is, again, public class. Let's give a different name this time. Let's give a name test2, okay? So, and then I need to go and do public static void main string args, right? Okay. And I'm going to use scanner class again. So I'm going to go and do import java.util.scanner. Okay. And then I'm going to create a scanner object. Remember, new keyword is used to create an object. You don't need to know any one of those yet. We are going to learn about them, system.in. So I created scanner object. This time I will say string name and then integer score, okay. And I will say system.out.print, enter your name. Okay, and then I'm going to read the name. I will say name via scan, but which method? Can it be nextInt? No, because I'm going to read names. It's a string. Can it be next double? No, I will have next line. So I'm going to read the whole name. Then I will say system.out.print. Let's do print. Okay, enter your score. I think we may have a little problem here, but I will fix it. Score is equal to scan.next int. I'm going to replace this 2 to avoid any complications here. Okay, so here, and then I will say system.out.printf. I'm going to use printf. Your score, your name is %sign s because it's going to be string, and your score is %sign d, and then I will say name score. Let's see if this will, okay, let's save it as test2.java. Why? Because the name of the class is test2. Now I have test2.java. If I say ls, you will see test2.java. Do I have test2.class yet? No. Why? Because I haven't compiled it yet. When I compile it, java c test2.java, it will compile, and there is a typo. Of course, this is not like that. System. Let's see if there are any other errors. I'm sure you can see things better than I do here. And now I'm going to, as soon as I compiled, what happened? Now I have test2.class. I can also list them here, test2.class. Now I'm going to run java test2. It says enter your score. Let's say 98. Okay. Yeah, here is the trick that I was trying to avoid. This should be next, not next line. So I'm going to go and compile, run again, enter your score 98, enter your name, Ali, and your name is Ali, and your score is 98. Okay, so I hope this is clear. And in order to write a program, you first do public class name, left and right braces, public static void main, static and public can switch, but the rest should be exactly as it is. By the way, this doesn't have to be args. It can be anything. I mean, like X, for example. When we learn about that later, you're gonna see, you know, it's there's a reason for that. You compile, compiles, you run, no problem. Okay, and then it runs. I hope you enjoy it. I mean, this is not that difficult. So this was our first lecture. In the second lecture, we are going to talk about control structures. They're pretty straightforward in any programming language. Look, if you learn Java, Python will be trivial for you. And if you learn C++, you know, one language is sufficient to learn the concepts. And the languages only have differences in what? Their syntax. For example, C++ is object-oriented, Java is object-oriented, that means they are class-based. C is a functional programming language. The main unit is a method. Python is both functional and object-oriented programming language. So it's a mixture of them. So every programming language has its own advantages and disadvantages, but Java is beautiful, and I hope you will enjoy learning this.